So today's topic is we'll be solving a problem sum on production. This sum will involve ISO costs and ISO quants and obviously a production function. So the production function or the problem is as follows. A firm has the production function y equals minimum of L plus 2k and 2L plus k, where y is quantity of output and L and k are the quantities of labor and capital inputs respectively. If the input price of L labor is rupee 1 and the input price of K capital is rupees 2, then to produce Y equal to 12 costs the firm at least, and then they have given 4 options. So we need to essentially find the minimum cost that the given firm incurs to produce a total output of 12 units. So the first thing that we need to find out is the relevant ISO costs, ISO quants, which are pertaining to our production function of y equal to minimum of L plus 2k and 2L plus k. Now, an ISO quant is essentially a combination of factors that produce a certain amount of output. So let's say we take certain input values and we find out the ISO quant for our corresponding production function. So I have certain inputs taken into account. So let's say we have a case where we have taken 2 units of labor input, 2 units of capital input. So according to my production function, my total output will be minimum of 2 plus 2 times 2 and 2 times 2 plus 2. So what I've done is I have replaced L equal to K equal to 2 in my production function, and I find out that my output production will be 6 units. Similarly, for L equal to 1 unit and K equal to 4 unit, my production function gives me 6 units of output. Again, if you put 4 units of labor and 1 unit of capital into the production function, you again get 6 units of output. The same output is received if I put 1.5 units of labor and 3 units of capital, or 3 units of labor and 1.5 units of capital. Now, if all these 5 combinations of input give me the same amount of output, which is equal to 6 units of output, then connecting these 5 input points, these 5 input combinations of 2, 2, 1, 4, 4, 1, 1.5, 3, 3, 1.5, we will get the ISO quant for y equal to 6. Now, this ISO quant for y equal to 6 will be kinked at 2, 2. So I'll be showing the diagram for this particular ISO quant, and we'll be showing that this ISO quant for y equal to 6 is kinked at 2, 2. Similarly, we can get ISO quants for y equal to 14 and so on, 14, 12, whatever amount of output that you wish for, you can get an ISO quant for that particular amount of output. Now, the lines L plus 2k and 2L plus k are relevant in our production function. So as I know from the production function y equal to minimum of L plus 2k and 2L plus k, I will try to find out a diagrammatic representation of my ISO quant. So what I essentially do is, since the ISO quant shows the combination of factors that produce a certain amount of output, let me consider that certain amount of output to be small q. So what I essentially do is I consider L plus 2k equal to small q and 2L plus k equal to small q, and I join these 2 line segments and I try to find out my relevant ISO quant. Now, if I find my ISO quant, I will see that these 2 lines L plus 2k equal to q and 2L plus k equal to q intersect at a point where x equal to q by 3 and y equal to q by 3. So this x equal to y equal to q by 3 is essentially the kink of the ISO quant that I mentioned before. Like for the amount of output of 6 units, I got the kink at 2, 2. So you can see in this diagram that if my quantity of output is 6 units, and if I draw the line L plus 2k equal to 6 and 2L plus k equal to 6, my kink comes out to be at the point 2, 2. This point, this kink point essentially is the point which is closest to the origin of the given ISO quant. So you see ISO quant pertaining to this production function, my ISO quant is essentially 2 segments of straight lines. So to the left of the ISO quant, to the left of the kink point, I take the steeper red colored line segment, and to the right of the kink point, I take the flatter blue colored line segment. So that is how my ISO quant looks for q equal to 6 units. But my question says that the output needs to be 12 units. So what I'll do is I'll try to justify, or I'll try to correlate between the ISO cost and the ISO quant, sorry. Now my linear cost function in this case is C equal to L plus 2K, because you see the input price of labor has been given to be rupee 1 and the input price of capital K has been given as rupee 2. So if I employ L units of labor, then my labor cost will be L, which is L times 1 essentially. And if I employ K units of capital, then my capital cost, rather capital expense, will be 2 times K, so that will be 2K. So my total cost, total production cost, is the summation of labor cost and capital cost for this situation at least. So my linear cost function gives me C equals to L plus 2K, where C is the cost that I incur as the producer. Now the equilibrium is attained at a point where the given isoquant touches the lowest possible isocost line. So as we know, an isocost shows all combination of factors that cost the same amount of output, cost the same amount, and isocost and isoquants can show the optimal combination of factors of production to produce either the maximum output at minimum cost, or in our case, a given amount of output at minimum cost. So as I mentioned before, the kink of an isoquant is closest to the origin. So if I need to consider the minimum cost that pertains to a given production function, then for our particular production function, since the kinks are always closest to the origin, all my equilibrium values will lie along those kinks. And those kinks lie along an expansion path y equal to x, where x equal to y equal to q by 3. So that is essentially my relevant expansion path. All my equilibrium points will lie on that particular expansion path. Now in this diagram that I have drawn, the dotted segments are essentially kind of the irrelevant lines. So the green for positively sloped straight line shows the relevant expansion path where x equal to y, and in our case x equal to y equal to q by 3. And the red dotted line and the blue dotted line are essentially the isoquants or parts of the isoquants for q equal to 6, which was used in my previous explanation. But the continuous red and blue line, they are essentially the points which correspond to my output of 12 units. So as I had mentioned before, the kinks are at point q by 3 comma q by 3, that is x equal to y equal to q by 3. So if I take q, the amount of output as 12, then q by 3 gives me 12 by 3, 12 by 3. So as you can match from the diagram, the kink is at point 4 comma 4. Now we are concerned with the isoquant that corresponds to the production function, production value y equal to 12, as I've mentioned before. And pertaining to the diagram, we can still see that the kink of the isoquant is at q by 3 comma q by 3, which is 4 comma 4. So as I mentioned before, since the kink point is the closest to the origin, this kink point will correspond to the lowest isocost for our given isoquant at q equal to 12. So my equilibrium point will be at 4 comma 4. Hence, the total amount of labor and capital that I invest in my production is L equal to 4 units of labor and K equal to 4 units of capital. Hence, the total cost that I incur for this particular production is 4 times 1 plus 2 times 4, rather 1 times 4 plus 2 times 4. So because 1 is the cost for labor per unit of labor and 2 is the cost of per unit of capital. So I have the total cost incurred as 4 plus 8, which is 12 units. Hence, my answer is 12 units. So going back to the question, the firm was following a production function of y equal to minimum of L plus 2K and 2L plus K. And if the quantity of output is 12 units, then the firm needs to incur at least a minimum cost of 12 rupees. Thank you.